Hey everyone! So in the last video, we actually learned how to do a few of the descriptive statistics in R in a really basic way, but we're going to now step it up a notch. We're going to install some add-ons or some new packages into R that will allow us to get out those descriptive statistics in a sort of easier way. So let's get right into it. Okay, so that's not too bad so far. But the thing is that there are much easier ways of doing most of these things. So what you'll find out in R is that there's always multiple ways of doing things. And I think there are easier ways of getting our descriptive statistics out in R. So the first thing we're going to do is actually learn how to install a new package. So what's really great about R is that it is sort of infinitely expandable. And because it's free and open source, you've got all kinds of really smart people who develop these packages or add-on packages that allow R to do these more complex functions that aren't actually already built into R. Over behind me here, we've got a tab called Packages. And you see it sort of shows, oh, there's a whole bunch of packages here already. These are ones I've got installed. Yours probably won't look the same, but that's okay. But we've got two different ways we can install new packages. One is just to click on this install button right here. So if I click install, it asks for install from. You just leave your repository CRAN there and just start typing a package that we want. So one of the packages that we're going to install right now is actually called the tidyverse. And the tidyverse actually includes a bunch of different packages that we're going to be using in later videos as well. So you're going to want to install those, and it will give you a bunch of different extra functionality within R that we're going to be using. So let's search just tidy. You'll see that there's a whole bunch of options that pop up, but just keep typing VER. So tidyverse is the last thing. I can actually hit tab to convert or to complete that. And I'm going to hit install. And what we'll see is this will take a little bit of time. If you watch the output panel down here in the bottom corner, we'll start to see it's doing its job, downloading and installing a bunch of different packages here. So it's downloading them. Right. Mine's already done. It's because I already had it installed. Yours will take a while. It'll do a bunch of different things. Once you get your little cursor come back here in the bottom, it means it's done and it's ready to go. So in order to use one of the packages that we've installed, we have to tell R to load that package. So it's not going to automatically load that package, but what we do is we use a command called library, and we tell it which package we want to load. So I'm just going to put in tidyverse, tidyverse here, and we'll see that it'll load up a bunch of different packages. So it actually loaded the tidyverse, which includes things called dplyr, forecats, ggplot2, etc., purd, blah, blah, blah. So don't worry about that. It's going to tell you a couple of conflicts, but don't worry about those. Okay, so the reason I wanted to do this at this point is we're going to be using this tidyverse in the next step, but I also wanted to show you how to load new packages or to install new packages. So one of the ways, like I said, was to click on this package tab and hit install. If you want to, you could also just use a command, which would be install.packages and then the package name you want. So in this case, tidyverse. And I can hit enter, and I made a mistake. I got an error in the bottom corner. It says error in install packages, object tidyverse not found. Now, what we need to do is find out what this error code means. I was like, oh, error install object object tidyverse. So it thinks I'm looking for an object, which is up here, and that's not what I want. I want to install packages, and specifically it's in quotes called tidyverse. Now, if I run that, it does the same thing. It says one or more packages need to be updated, are currently loaded. It's highly recommended to restart R. I don't know why it does this, because it just goes into a loop of saying the same thing each time. So when it asks me, do I want to restart R prior to install, I just say no. And then it runs what it did, which basically gave me the warning. It's already in use and it won't be installed. That's because it's already there. But I just wanted to show you that you can use this command, install packages, as well. In fact, I'll put it just above tidyverse there. It's just above the library command. So you can see that what this is actually supposed to do. Okay, so now that we've got this tidyverse installed, we can start to use this to help us do a couple different functions that we want to do to help us make our lives easier when trying to do descriptive statistics. So the first thing we're going to want to do is let's create a new object that is going to be heights F. And that's just going to be the heights of females only. And we're going to use one of the functions included in the tidyverse, which is actually called filter. And what filter does is it allows you to select certain rows based on the value of a column. So in this case, we can select certain rows that we want, and that would be values that have F in the sex column, and only those rows we want to keep. That's what we'll filter. We want to keep these specific rows. Now, we'll get into how to use filter a lot more in the next tutorial, but right now I just want you to follow along and sort of see what this is doing for you. So we're going to filter heights underscore long. So we want to filter that data frame, which is one of these objects, and then we have to tell it what we want. And I want to filter it based on sex. And I have to tell it which sex I want. Now, I needed to make a logical comparison. And when we use logical comparisons in R, we can use equals, but we have to use a double equal. So sex equals F. So in this case, I'm saying does sex equal F or not? Now I'll show you another example we could say is does sex not equal F? Or does sex definitely equal F? Or is sex greater than or equal to F? But that makes no sense in this case. We would not do that. So when we're doing logical comparisons, we need to use a double equals in this case. So into heights F, we're going to filter heights long where sex is equal to F. I hit Control Enter, and we see I get a new data frame where there's 20 observations of two variables. So now I only have in this data frame females. Now I can do the exact same thing, copy paste that, and just change that to heights M and filter where sex equals M. Or another way I could have done that is into heights M, I can filter heights long where sex is not equal to F. That means it has to be equal to M. So that will do the exact same thing. So these two commands are functionally equivalent, where sex equals males or sex does not equal female. It's the same thing. So now let's run a bunch of descriptive statistics on each of these two sets that I've now split apart, because using that tapply function doesn't work for really everything we want to do. So one thing we may want to do is create a temporary data frame. And into that, we're going to put heights F. And I'll show you why we're going to do that in a second. Now, we're going to attach df. That means I'm going to take heights F. I'm going to basically copy it into another data frame called df. Now I'm going to attach that df, and we're going to do all the things we did earlier for this, right? So we're going to say mean, median, standard deviation. But instead of females, we need to now say height. I'm going to copy this, double click, paste, double click, paste. And we're going to get mean of height from this heights females, putting it into data frame. In df, I'm attaching that and taking the mean height, median height, standard deviation height. And then there's a whole bunch of other things we could do. We could say, what's the min height? What's the max height? Remember, because I copied height, either Control C, and then I can paste it very easily. I can use the command range heights. I can look at the range in a different way, which would be max height minus min. Right. Oop, forgot a bracket there. What else do I want to put in there? I can also use IQR. So that's interquartile range of height. And then I would want to detach df. Remember, because that's the one that I attached before. Now, if I take that whole set of commands and run them, what we see is I get a mean, median, standard deviation, min, max, and oh, I made a mistake clearly in here. Yeah, I've got, we can see that I've got an error range. Gives me my range, which is 152 to 180, but then I've got this command here where I totally messed it up. So I've got max height minus min height. So I forgot a bracket there. So if I actually just run that whole set of commands again, I actually should get, now my max height minus min height gives me my actual range, which is 28. And then the interquartile range, which is 13.25. Now, the reason that I wanted to do it this way is that it's really easy now for me to change that to get my male data. So instead, I could maybe, if I want, copy this whole set, Control C, drop it here underneath it, and just change heights F to heights M. Now I don't have to do anything else. I can run this whole thing, and that gives me all the data for the males. So I've got mean height 181.75, median 182, etc., etc. We see our range and everything is different, and I've got all that data. Lastly, it's funny that I've just shown you all of these different ways to do this. This is one of the things I said about R at the beginning, said we can get at all these different bits of data in different ways, and maybe the easiest way is to say summary heights underscore long. Now, if I run that, what we see is it gives us the minimum, the maximum, the first quartile, the median, the mean, the third quartile, and it gives me sex, male, and sex. There's 20 females and 16 males. So we can see that that is summarized sort of across both of the sexes. So if I had actually added this summary, in this case, summary of height for our males and for our females, I'm going to copy that and put it into there at the end. that will also sort of duplicate some of the data that we've got. So if I run that whole set again, we can see that for the males, we have mean height is 180, 1.75. It tells me that again. And I've got my quartiles. So I can get all of that data. So now I wouldn't actually need to use the interquartile range if I don't want, or the min or max values. I can just run one single value here. That sort of makes, for example, those two and maybe those two redundant, right? So like I said, there's also other ways we can get descriptive statistics. One of the ways might be by using a different package. So these are the ways we can do it in the base package of R, but we might want to use another package that will allow us to calculate the descriptive statistics sort of in one line. So I'm going to install a package called pastecs. So if we use install packages, it's called pastecs. So that I can install. It's going to probably tell me that it's already done, successfully unpacked and checked, and it's downloaded, and we're good to go. So the command to, so in pastecs, there's a command called, first of all, I have to load that library called library pastecs. Okay. There is a command called stat.desc, which is basically descriptive statistics. And we want to use the heights underscore long. And we could just say that. Why don't we just do that right off the bat? And if I run that command, now what you'll see is we get all these different values. And, they're shown in scientific format here. So one thing we might want to do is actually change that. So it sort of spits out kind of easier to read values. And this is one thing I almost always do at the beginning of my script because I find it more difficult sometimes to read some of these scientific notation values. So in fact, I'm going to put this right up at the very top of my script. And the command that I use is called options IPen equals 999. Ooh, 999. And if I do that, what it does is it stops it from showing scientific notation. So I'm going to run that command. We'll go right back down to the bottom of my script, and let's run that stat.desc again. Now you see that I get a value that is actually a little bit easier to read. So there's 36 values, my min and my max. But remember, this is across both groups. It gives me a range, sum, median, mean, standard, error, confidence intervals, variance, standard deviation, coefficient of variation. So even more things than we'd seen previously. So the problem is that this one won't allow us to look at our descriptives by group. So what we're going to do is use a different library this time, and I'm going to install.packages another library that's actually called psych, P-S-Y-C-H. All right. You'll see that it installs that package. Great, good, done. And we're going to use a function called describe. Oh, we have to install, or we have to load that library again. Library psych. Okay. And now we're going to use a function called describe. Describe heights underscore long. But again, here I have to tell it which column I want. So I'm going to describe heights underscore long height. And if I run that, it shows us my variables. There's 36, 172.19, And that's going to be the same sort of values as I got out here, right? So mean was 172.19, et cetera, et cetera. I've got, all kinds of different range of values, again, that it's giving me for my descriptives. The strength with this package, though, is that we can use a function called describe by, right? So here it's describe capital by. And here we need to use what we want. We want height, and then we use the little tilde. And now the tilde being the little squiggle. I don't know if you can see it if I zoom way in here. Make sure that you can see that little squiggle guy, right? So it is beside the 1 on your keyboard, or it's a little apostrophe. All right. So we're going to describe by height, and what this little tilde means is as a function of, or by, right? So height as a function of sex, and data equals heights underscore long. Control Enter. Now what we see is we get descriptive statistics by group. So sex females, I've got 20, my mean, standard deviation, median, trimmed, mean, max, range, skew, etc. And we have the same for males. Okay, so that's a really easy way for us to get all of our descriptive statistics in one line by using this package called Psych, which is really super useful. All right, so really that gets at how we can really easily get our descriptive statistics out from our data. And well, also installing some new packages and loading those up. The next video is going to look into using a couple of brief visualizations of our descriptives and looking at a few of the error messages you might encounter when you make mistakes, like you saw a couple that I made in this video. All right, so check out the next one.